let's review so far what we know about using summation notation. So first we have some properties of sums. If we have a constant, then we can pull that constant outside of the sum. And if we have the sum of two things added together, then we can just look at those things individually. And same thing goes with subtraction. And we also looked at some special sums. So if we have the sum from k equals 1 to n of a constant, that's just n times the constant. And if we have the sum from k equals 1 to n of k, that was n times n plus 1 over 2. The sum from k equals 1 to n of k squared was n times n plus 1 times 2n plus 1 all over 6. And finally, we looked at this one, k equals 1 to n of k cubed. And that kind of looks like the sum that we had for just plain old k. We have n plus 1 over 2, but then we have that whole thing squared. Okay, so let's look at how to actually use these properties and these special sums. So here are the special sums. We're going to use those, so I'll put them over here on the side. And first I want to look at this. This is the sum from k equals 1 to n of 5k squared plus 2k plus 1. So first of all, we know that if we have a bunch of things added together, what I could do is rewrite this using three different sums. So I can rewrite this as k equals 1 up to n of 5k squared. And then I can rewrite it as another sum here, the sum from k equals 1 up to n of 2k. And then lastly, I have a 1 here. So this is the sum from k equals 1 up to n of just plain old 1. Okay. So that was using one of the properties of sums. So now what I want to do is figure out how I can break this apart. Well, these constants here, this 5, that does not depend on k at all. That can come outside the sum. So I can rewrite this first sum as 5 times the sum from k equals 1 up to n of k squared. And then I can do a similar thing here. This 2 doesn't depend on k. That 2 can come outside. So I can bring the 2 outside the sum. So then I have a 2. And I have the sum from k equals 1 up to n of just plain old k. And then the last one, well, that's just a 1. I might as well just leave it as a 1 here, a constant. So k equals 1 up to n of 1. Okay. Now I can use these formulas on the side here. So I have a k squared, that's going to be this one right here. And I have a k, that's going to be this one right here. And then I have a constant, that's going to be that one right there. So those are the three formulas I'm going to use. So first I have 5 times the sum from k equals 1 to n of k squared. That's this right here. So that's going to be 5 times, and then I'm going to have n times n plus 1 times 2n plus 1. And then all of that is over 6. That's the first sum. Okay, next I have a 2, and then I'm going to have, so let's say I have the sum from k equals 1 to n of plain old k, that was this one. So that's going to be n times n plus 1 all over 2. And then lastly, I have a sum from k equals 1 to n of just plain old 1. Well, I can think of this constant here as being 1. So this is going to be n times 1, or just n. Okay, now let's simplify this as much as I can. So this looks like, well, it's going to be a 5/6, and then I'm going to have an n times, and then I might as well multiply this out. So what would this be? N times 2n, that's 2n squared. And then n times 1 is n, but then 2n times 1 is 2n, so 2n plus n, that's going to give me 3n for the cross terms. You can write it out if you need to. And then 1 times 1 is 1. This one, the 2's are going to cancel, which is nice, and then I'm just going to get n, and I guess I'll multiply this out too. So it's going to be n squared plus n. And then I have my last plus n right here. All right, so now I have 5/6 times, and I can multiply an n through this. So I'm going to get 2n cubed plus 3n squared plus n. And then I have plus n squared, and then n plus n is 2n. All right, Let's see. Let's multiply the 5/6 through. So I'm going to have, in this case, 5/6 times 2. That's going to be 10/6. But I can reduce that. 10/6 has a common factor of 2 in it, so that's going to be 5/3. So this will be 5/3 n cubed. And then this is 5 times 3. That's going to be a 15, but then 15 and 6 have a common factor. Or you can think of it as, I'll write it over here so you can actually see what I'm doing here. 5/6 times 3, which you can think of as 3 over 1, and then we see a common factor here. So this is really going to be 5/2. So this is 5/2 n squared plus 5/6 n plus n squared plus 2n. And the last step, I can combine like terms. Well, there aren't any other n cubed terms, so that's going to stay a 5/3 n cubed. We have 5/2 n squared plus n squared. Well, 5/2 plus 1, I can rewrite the 1 as 2 over 2, and that's the same thing as 7/2. So this becomes 7/2 n squared. And then I have 5/6 plus 2. Those are my n terms. Okay, so 5/6 plus 2. I need a common denominator here. It looks like it's going to be 6. So that stays a 5. This becomes a 12. And so then I get 12 plus 5. 17/6. So this becomes 17/6 n. And that's about as simple as you can get for something like this. All right, let's look at another example. How about the sum from k equals 1 to n of 2k cubed minus 9k? Okay, so for something like this, we want to do the same kind of procedure. I'm going to break it apart. So I can rewrite this as two different sums. I can rewrite it as, and I'm going to skip a step here. I'm going to pull the 2 out also. So this is 2 times the sum from k equals 1 up to n, and that's going to be a k cubed, minus a 9 times the sum from k equals 1 up to n of k. And so now I have a k cubed and a k. So I'm going to use that, and I'm going to use that. Okay, so this is going to be 2 times, and now I have the sum of k cubed. That's this thing right here. So that's going to look like n times n plus 1 all over 2 squared minus 9. And then I have the sum of k. That's this formula right here. So it's going to be n times n plus 1 over 2. All right. So now let's simplify. So this is squared. So let's square it out first. So that's going to look like n squared n plus 1 squared all over 4. And this is going to be 9/2 times n squared plus n. Okay. Well, the 2 and the 4 can cancel, and I'll be left with a 2, so that'll become a 1, and that'll become a 2 downstairs. So this is going to be 1/2 n squared, and then I have n plus 1 squared. Well, n plus 1 squared, I can square that out if you need to write it out. I can think of it here. So n plus 1 times n plus 1. So I have an n squared. Then the cross terms, I'm going to have a 2n. And then lastly, I'm going to have a 1 and a 1 is going to give 1. And then minus 9/2 times n squared plus n. Okay. So now let's simplify a little bit more, and then we can combine like terms. I have this n here that can be distributed through. So this will be a 1/2 n to the 4th plus, and the 1/2 and the 2 will cancel, and then I'm going to get an n cubed plus, and then I'm going to have a 1/2 n squared. And then here I'm going to have minus 9/2 n squared minus 9/2 n. Distribute that minus sign right there. All right, we're almost done. Let's see, we have just 1 n to the 4th, so that's 1/2 n to the 4th. Just 1 n cubed. And then I have 1/2 minus 9/2. And so when you do 1/2 minus 9/2, I'm looking at the n squared terms here. 1 minus 9, that's -8. So that's going to be -8/2, but -8 divided by 2 is -4. So this is just -4n squared. And then I have a minus 9/2 n. And that's about as simple as you can get. Okay, let's try one more example. Suppose I wanted to look at the limit as n goes to infinity of this sum right here. So it's the same thing we did in the previous two examples. I'm just adding a limit out front. And so I'm going to kind of ignore that limit until the very end when I get everything in terms of n, and then I'll do the limit. So I'm going to keep writing it, but really we're not worrying too much about it until the end. So I'm going to rewrite it. I have a limit out front. I have a limit as n goes to infinity, and that's just going to stay there until I finish. So now let's look at this sum. So this is 4 times the sum from k equals 1 up to n of k squared, plus the sum from k equals 1 up to n of k, minus the sum from k equals 1 up to n of plain old 2. And now I'm going to use, let's see, I have a k squared, I'm going to use that. I have a k, I'm going to use that. And I have a constant, so I'm going to use that. So I'm going to keep writing the limit outside. Remember, I'm just going to keep writing it until the very end. Limit as n goes to infinity of, okay, 4 times k squared. So it's going to be 4 times this thing right here. So that's going to be, well, I'm going to have a 4 and then I'm going to have a 6 in the denominator. That's the same thing as 2/3. So I'm going to write that as 2/3 n plus 1, 2n plus 1. So you see there's a 4 out front, there's a 6 in the denominator. So that would be like having a 4 right here. The 4 and the 6 will really make it 2/3. That's where that came from. Plus, now I just have the sum of k, that's this formula right here. So that's going to be 1/2 n times n plus 1, minus, and then I have a 2. Remember, when you have a constant, you just have n times the constant, minus 2n. Keep writing the limit out front, so I have the limit as n goes to infinity of this thing right here. And so I can simplify this. I have 2/3 n, and then this is going to be 2n squared. I'm going to have an n plus a 2n, that's going to be a 3n, plus 1, plus 1/2 n squared, plus 1/2 n minus 2n. And then I'm going to keep writing the limit here. I have a limit as n goes to infinity of, and now I can make this 2/3, and now I have this n to distribute here. So it's going to be 2n cubed plus 3n squared plus n plus 1/2 n squared. And then I have 1/2 minus 2. 1/2 minus 2, I need a common denominator here of 2. So this is going to be 4 over 2. 1 minus 4, that's -3. So this is -3/2 n. Now you might guess at this point here, just looking at this thing here, that the limit of this thing as n goes to infinity. Well, let's see, I have a bunch of powers of n here, and it looks like this thing is just going to go off to infinity. So I could stop right here and just say that the limit of this thing is going to be infinity. It's going to get larger and larger here. I have these n's to the 3rd and 2nd power here. So this kind of thing where you have a limit as n goes to infinity outside of a sum that has a bunch of things here that you can turn into things with n using special sums here. All these k squareds and k end up becoming things in terms of n, and that allows you to take the limit. That kind of thing is the thing that you see in calculus. And it's really not that complicated if you just break it apart, ignore the limit until the very end, and just focus on the sum and work with the sum until you get something that's in terms of n and allows you to actually take the limit. And then at the very end, go ahead and take the limit.